Hi, and welcome to Lesson 2 of Mastering OEE. My name is Christian Lindvall, Head of Sales EMEA at FactBird, and today we'll dive into the three components of OEE. The goal of this lesson is to give you a basic overview of the three components of OEE. First, we'll take a look at what those components are, and then we'll discuss how they relate to each other. Typically, production optimization specialists calculate OEE as a relationship between three components: performance, availability, and quality. Availability focuses on the planned production time and how effectively it is utilized. Here, it's important to ask how long the machine or system has been operating. According to Nakajima, OEE considers downtime events that halt production, allowing an insight into overall operational availability. But this can differ between OEE calculation methods. Performance measures the speed at which the manufacturing process operates compared to its maximum potential or design speed. This component of OEE helps in identifying whether more products could potentially be produced during the allocated production time. Quality assesses the number of products meeting the quality standards against the total number produced. Quality losses can include defects, rework, and scrap. This component is crucial for understanding the waste generated due to defective products. The three components of OEE each play a crucial role in the overall effectiveness of equipment. Availability impacts the amount of time production can occur. Performance reflects the speed and efficiency of the production during this time. And quality ensures the output meets the required standards. Improvement in any one of these areas can positively affect the overall OEE score, but true effectiveness is achieved when all three components are optimized in tandem. Availability is quite clear. Increasing production time would improve OEE. You can see an example of non-planned production affecting bottles per minute produced in the image taken from the FactBird Cloud application's stop registration dashboard. Increasing production speeds can help you produce more units. But does your primary goal of units conflict with your, say, secondary goal of reducing scrap and rework? Higher speeds can lead to higher quality losses and more breakdowns. So how do higher speeds affect scrap counts in this example? We would need to correlate the speed data to the scrap data and make a strategic decision about how much we want to focus on quality versus speed and total output. Focusing solely on quality can lead to inefficiencies in production speed and vice versa. How about in this example? Would it make sense to turn up the production speed to produce at higher rates? Without timely, accurate, and complete production data, it's very hard to make a smart, strategic decision. By monitoring and improving each of the components of OEE, using real-time data and OEE analysis software, you're more likely to achieve a more efficient, productive, and profitable manufacturing operation. So, I hope this introduction to the three components of OEE was helpful for you. Next up, we'll deep dive into Nakajima's OEE calculation and how each component is calculated.